First things first, ensure you have Python installed. Then, grab pygame by running pip install pygame in your terminal. We'll initiate pygame by creating a window with dimensions 800 by 450. Let's not forget to update the window's color frame by frame, and always remember to put an exit condition. We don't want programs to run forever. Imagine our character as a simple box, centered on the position. This representation enables flexible movement within our game environment. The width and height captured in a 2D vector define the character size. Translating this concept into code, our character definition will look like this. Typically, you'll find two distinct methods, one to calculate data and another to render it. However, for simplicity, we'll merge these two into a single method for now, which draws a box that respects the player's position and size. To reposition the player from the corner to the center of the screen, we'll offset its position. This involves shifting it by half of the screen width and half of its height. Let's draw inspiration from physics for a second. Introducing a 2D vector called velocity, which determines the player's movement. Each frame will adjust the player's position in alignment with this velocity vector, basically moving the player towards the velocity direction. Consider this, setting the velocity to 10 initiates slow movement to the right. However, to control the pace, we'll scale this vector by a chosen factor, say 10. Experiment with the scalar value, the higher the number, the faster the player moves. Once you found the ideal speed, assign it as the player's work speed. Now let's introduce a conditional movement. While the D key is held, the player moves to the right. Holding A will move them in the opposite direction. When neither of those keys is held, we reset the velocity's x component to 0. However, for a more dynamic and responsive movement, an alternate approach is to gradually decrease the velocity's x component. You can achieve this by dividing the velocity's x by a number each frame when there is no input. Introducing jumping functionality involves manipulating the velocity's y component. By detecting key presses using pygame events, we can specifically monitor when the player hits the spacebar. Upon detecting this input, we'll modify the velocity's y component to -20. In computer graphics, the y-axis typically extends downwards, so a negative value like -20 in this case signifies movement upwards by 20 pixels, enabling the player to jump. Let's assign a jump power property to 20. Well, the player literally jumped to the sky. To counteract this, let's introduce gravity. For a simple implementation, we can consistently increment the velocity's y component by some gravity acceleration constant, giving the illusion of a mysterious gravity force pulling the players down. But we have a problem. The player is now overwhelmed by gravity and simply falls off the screen. Usually we don't fall through the floor because a normal force gives us a push and overrides our weight. Okay, so in real life we find this force that pushes us upwards, basically making the weight insignificant. But for lazy programmers like us, we like to create our own universes with our own rules. We can just erase the entire concept of gravity once the player falls below a certain line. So once the player's y component gets greater than, let's say, 300, we can simply pretend gravity doesn't exist, setting the velocity's y to 0. If you are observant, you will have noticed that we execute all of those calculations in every frame, which presents a problem. If you have a high-end PC, your character will move too fast since you perform too many frames per second, or vice versa. To bring balance to your game, consider making the velocity relative to the time taken for each frame to load. Typically we denote this time as delta time. In pygame, calculating delta time is a straightforward process. Begin by initializing a pygame clock and invoking the tick function within each frame. While tick's primary role is to establish an FPS gap for our game, its output, delta time, becomes especially valuable here. Multiplying the player's velocity by this value will ensure overall consistency in the player's movement. Now that delta time influences your character's movement, it's essential to reassess the optimal values for parameters like work speed, gravity, and jump power. Let's add the final touch to our player. We can't just leave it as a boring box. So I have in the same folder as a Python file a ufo.png image, which I will use as the character avatar. Pygame gives us the ability to import images with ease. So inside the player's initializer we can create an image property, which will serve as our player's character. First we load the image, then we convert it and finally scale to the player's size. In the draw method, forget about drawing the rectangle. Instead, we'll display the image on the screen using the breathe method, which requires the image we want to showcase and its top left position. Thank you for reaching the end. The code is in the description, and again, all of these concepts can be applied to any game using any library, so don't get limited to pygame. If you want to support this channel, you can watch the 2 ray tracing videos, or that nice math problem, maybe even the pathfinding tutorial, and that's about it because the rest are garbage. As always, if you have any questions, ask them in the comment section down below, and see you next time.